So in the test today, we're going to be experimenting with how 3D printed wall thickness impacts the strength of a cantilevered beam. So within the parameters of this video, in order to test wall thickness, we go all the way from a very standard 1mm wall thickness all the way up to a 5mm wall thickness. We are using 20mm cantilevered rods inside of a compression testing rig, and those rods have the force applied 40mm from the point of rotation on the rod. This allows us to get a good ratio of both strength to weight as well as the actual stress strain graph that this could create from the base data that we get a hold of. Now, generally in this sort of situation, we would expect that the wall thicknesses will have a fairly nominal increase to the overall strength of the part. Wall thickness is very much like the flanges of an I-beam. The thicker they are, the stronger the I-beam is. Though, of course, making the I-beam wider would make it stronger. But here we're going to see the thickness of the wall start to encroach, so you would expect to see kind of diminishing returns from the wall thickness as time goes by. But let's go ahead and look at the tests. So the very first wall thickness that we'll look at is the very standard 1mm. This is often the default for many 3D printed setups. And as we set up inside of there, we see a good amount of deflection before finally having just about full failure after a good amount of deflection. But ultimately, we ended up with about 150 newtons on that test. Now moving on to the 2mm wall thickness. This increases the weight by about 50% to 12.3 grams, and a decent amount of print time increase. As we would expect from wall thickness, it takes quite a bit of time. But ultimately, it breaks down at 142 newtons, with a secondary test going up to 204 newtons. So a good spread, but overall a reasonable average. Now moving up to the 3mm wall, a good amount of increase of material, but not as much as previously. Ultimately, this test ended up breaking at 316 newtons with an overall average hovering around there. But what's really interesting about this is that it was a very large jump in overall strength between the 2mm wall and the 3mm wall. But moving on to the 4mm wall now, we go ahead and see it start to compress there. Only about a 8% increase in overall print time from this, and a very small increase, about 20% in material used, for a large increase on overall strength, still hovering around about the 336 newtons. Very strong, just about as strong as the 3mm wall there, even though it has these increase in material usage. Now onto the 5mm wall thickness. Again, not a large increase in either weight or print time. And given the fact that this is PLA, we were seeing quite a bit of deflection on the actual rods. Again, they're a 20mm diameter with a 40mm contact point away from the point of rotation. But we have, again, an overall increase in strength, but we're not seeing a large increase in overall strength to weight with more wall thicknesses. But we have, again, a pretty large increase between 2 and 3. So overall, the wall thickness tests were kind of uninteresting. Generally, just a mild increase in wall thickness did not really yield either a dramatic change in overall strength to weight ratio or overall strength. The one exception to this was the step between 2mm to 3mm. There was a giant increase in overall strength between 2 to 3, and we're going to look at this more because there are a number of different geometrical reasons that this could be caused. It could be slightly indicative of just the overall profile that we're doing these cantilevered beam tests with, as well as a number of other factors. But right now it appears that going from just a 2mm wall thickness to a 3mm wall thickness radically increases the overall strength. And it doesn't really radically increase the amount of material used in this case. Generally, when designing 3D printed parts, you seek to minimize surface area because that's where most of the material is due to the walls. And since that's where most of the material is, that's where most of the print time is. So it's something that you kind of want to avoid, putting more materials in the walls if you don't have to. Generally, it's better if you want to make the part stronger, just increase the cross-sectional area. It's like making an I-beam longer. You increase its overall strength because the two flanges, in this case the walls, are farther away from the point of rotation, the sliding center line whenever you bisect a part. So it's not too surprising that wall thickness had a large impact on the part, but it was interesting that it jumped so suddenly. So do make sure to subscribe to this channel in order to see future tests, and drop us a comment down below of other tests that you would like to see on this channel. Have a great day, everybody.